So we're going to complete the square. And so how do we complete the square when we have an a value out in front not equal to 1? Well, first we actually have to common factor that out of the first two terms. And so that just leaves us with a nice x squared by itself. When you common factor -3 out, what happens to the positive 9? Positive 9 would become -3, right? Because -3 times -3 gives us positive 9. And then we leave the last term outside the brackets. Next, we do something to make it a perfect square. And this is kind of showing the work. So we have to add something here and subtract the same thing here. And we'll see why in a second. So to make this a perfect square, what is a perfect square actually? It's when we have a squared minus 2ab plus b squared, x squared minus 3x. If we have an odd number, it's a little bit difficult to come up with the last term. I'll show you what it is and then I'll explain how we got it. So if we have this, you might be able to see that we would be able to factor this with x minus 3 over 2 and x minus 3 over 2. If we were to FOIL this back, distribute it back in as a check, we should get what we had to begin with. So doing that, we'll get this. And you can see when we collect like terms in the middle, what's minus 3 over 2x minus 3 over 2x? So we get -6 over 2x plus 9 over 4. And you can see that this would reduce to -3, basically just to check to see that it was correct, because it's the same thing as before. The main question, I guess, would be, how do we get this? How did we come up with that to give us our perfect square, which is useful because then we can just write it once squared, which is what we're looking for in here. So how do we get this 9 over 4? Well, we take this middle value, let's call it b, and plug it into an equation that we know. This equation is very useful when x is just 1. So you just divide b by 2 and square it after we've common factored the -3 out. So here you can see the b would be positive 9, but we don't use that. We use -3 after our common factoring step. So if you just divide that by 2 and square it, I'll just plug in to show the work. So we'd have -3 over 2 squared. When we square it, the negative cancels, and so we'll get 9 over 4. After you've done this for a number of trials, you'll actually get the hang of it, and you won't actually have to do all these steps. I'm showing these steps for the people who are kind of new to this. So we have our two numbers here. What do we do with these two numbers? Well, we use one of them. We always use the positive one, by the way. The negative one will come outside, and we have to multiply by what we've common factored out, which was a -3 when we remove it. So we'll get plus 9 over 4, and multiplying by -3, we'll get 27 over 4 minus 1. You can see that this trinomial we've got in our parentheses is useful because it's going to reduce to the perfect square like we've seen before.
Yeah.
So I'll save some time. I won't show it in factored form. I'm going to go straight to the perfect square. Notice the similarity here between what I have in the perfect square and what I had from just doing b over 2 without squaring it. That's where we get our term in the perfect square. And then when we simplify this, we'll have 27 over 4 minus 4 over 4. So this would be 23 over 4.